I have a few homework examples prepared in section 12.3. There are three-dimensional figures that you will be solving for. One is the can, or the cylinder, which is the soup can here. The other, the cone, and then a sphere. Shown a few objects there. Obviously, you're well aware of these figures, that they're very common in our products that we see every day. So the can, the cylinder, we're looking at just surface area here. The surface area of the cylinder, since it is a CMP flat top, the surface area is going to equal the lateral area, and add that on to two base areas, because there's two bases. The lateral area we already know is the circumference of that base and multiplying it by height. So base times height plus 2 times the area of the base, which is a circle. So we have 2 times pi r squared. And that's because in a tin can, not only is the lateral surface area tin, but also each base, the bottom and the top, is also a tin. So we're going to have twice the area of the base there. So I don't think I need to do an example of this. If you were given information like this soup can, suppose this soup can was 5 inches in diameter and had a height of 8 inches, then I think without too much trouble you should be able to find the surface area by finding the area of the base, which is pi r squared, and multiplying it by the height, which is 8, adding it to twice pi, and then the radius there is 2.5. So I'll leave that and move on to something that you haven't seen before. Now the cone is not a CMP flat top, so we can expect some differences here, something maybe a little bit new. The cone does have a net though, so we're looking at the waffle cone, and if I wanted to know what the surface area of the waffle part or the cone part, I would be looking at the surface area of the cone. Now the cone does have a net, so if I take a cone, I'll draw it like this. If I take a cone and I peel the waffle off of it, I'm left with a circle, and that is the base. And we're familiar with the base. And then what I get is this, strange looking figure. So if you can imagine, this is the lateral area. And it's curved. If you can imagine me rolling this up into the cone there, I would have a cone. So now if I want to find the surface area, I want to find both of those. So surface area of the cone, so this is cone surface area, is going to again equal the area of the base, which is pi r squared, add it to my lateral surface area. Now, in order to find the lateral surface area, this is how I remember it. This appears at a glance to be somewhat like a triangle, with this being my base. It's not a triangle, but it resembles a triangle. This would be base, and this would be height. So the area of a triangle is 1/2 base times height. Now really this base is really the circumference of the circle. It wraps around itself. So that lateral surface area is 1/2 the circumference times what we call the slant height. This is the slant height. This is the circumference. Okay? So again, looking at my cone as it's drawn here, this distance is my circumference C. We know that to be my radius r. This distance that drops right down the center, that distance there is the height of the cone, and that is different than this distance here, slides down the side, which we call L for slant height. So what I have now is this. To find the surface area of a cone, I take pi r squared and add it to 1/2 the circumference, which is 2 pi r, multiply that by the slant height. So there's a formula for finding the surface area of a cone. So now let's look in context here. If this waffle cone is of interest, and I want to know how much waffle goes into that outside cone, I am going to be interested only in the lateral surface area. So I'm only interested in this part now, because an ice cream cone doesn't really have a base. It's filled with ice cream. So let's apply that in this case. Suppose I would need to know some information about this cone in order to do that. So I would need to know the slant height, and I would need to know the radius. So suppose the radius from center to outside of this cone is 2 inches. Okay, suppose that is 2 inches. Also, let's suppose I don't know the slant height, just to make it a little bit more tricky. So you see an example where you're not quite given, you have to solve for some information first. Suppose we know that the total height of the cone is 8 inches tall. Well, in order for me to use my formula, 1/2 2 pi, my radius is 2. Now I need to find my slant height. So what is that slant height equal? That slant height, notice that this is a right triangle, so it is so 2 squared plus 8 squared must equal my slant height squared. So my slant height squared equals 2 squared plus 8 squared, which is 4 plus 64, which equals 68. So my slant height is the square root of 68. Okay. Square root of 68 is approximately 8.24. We'll leave it just as square root of 68. Let's see, 68 does divide by 4 nicely, so it is the same as 2 root 17. 2 root 17. So there's my slant height. I'm going to multiply this by 2 root 17, and then simplify this. Okay, I've got 2 times 2 is 4, times 2 is 8. 8 divided by 2 is 4. This is 4 pi root 17. We're going to measure in inches. Inches squared. That would be the surface area of that waffle cone above. Notice that I did not add in a base because the cone itself did not have a base. So the lesson here that you need to remember is that lateral area really resembles a triangle. That's how I remember it. It resembles a triangle, which is 1/2 the base times the height. And this is your slant height right here. It's going along the side of the cone. So it's going along the side of the cone, right down the side. So we needed to find that, and we found it We found it by using the height of the cone and the radius of the cone. The last one is a sphere, like a ball, a baseball is a sphere, and your surface area is equal to 4 pi r squared. All you need to know is the radius. All you need to know is the radius of that ball. So this is made out of cowhide, leather. So how much leather goes into making a baseball? Well, if I'm not mistaken, the baseball circumference, the circumference of a baseball is equal to 9 inches. So 9 inches. So if circumference equals 2 pi r, 2 pi times 9, oops, I'm sorry, going backwards. I know the circumference. I apologize. If circumference equals 2 pi r, and 9 is my circumference, then divide by 2 pi, my r, get a little bit of room here, my r equals 9 over 2 pi. 9 over 2 pi. So my surface area is 4 pi times 9 over 2 pi. That quantity is being squared. Clean it up. So I've got 4 pi times 81 over 4 pi squared. I'm going to have one set of pi's cancel out there. I've got 4 up here. 4 will cancel with that 4. And I'm going to be left with, what, 81 over pi inches squared. So that is how much cowhide or leather goes on a baseball. 81 divided by pi inches squared. Okay, so that's some simple examples. Now let's do one that's a little bit more involved. So I'm just going to add a page here. I'm sorry. I'm going to do a new sketch. Clear this off. Looking at a homework problem, I'm looking at number 6. Number 6 is a good problem. I don't believe I assigned it, but we'll do it as an example. You get a kind of a peculiar figure that looks like this, where we have a half a circle. It's like a tub. You can imagine that tub there. This is a center of the circle, and that's the center of the circle. This distance is 5. This distance is 2. And we're asked to find the surface area of that solid. Okay? So a couple of things that I need to think about here. One, if I were to look at all of my shapes, I have got a rectangle. So if I'm going to find my surface area, I've got I need to find the rectangle area. That would be all of this. That's pretty straightforward. That would be length times width. So 10 units times 2 units is 20 units squared. So that's not a big deal. Now how do I find the rest? What I should notice is this is really a cylinder, half of a cylinder. So this is really half of a cylinder. So let's find the lateral area of half the cylinder, and I will be finding all of this all the way around. Okay, just that lateral area. So I'm going to take a cylinder, since it's a C and P flat top. I'm going to take the perimeter, half the circumference. So my circumference is divided by 2 is 2 pi r divided by 2 or just pi r. My radius is 5, so that's 5 pi. I'm going to multiply this perimeter and multiply it by that depth, which is 2. So my lateral area is 5 pi times 2, or 10 pi. So that gives me all the purple, and then I need this base in here. That base is a half a circle. So I've got half of a circle. A half a circle is pi r squared divided by 2, which is pi times 5 squared divided by 2, which is 25 pi over 2. Now remember, I've got a base here, and then I've got a base on the other side. So what we're going to do is we're going to multiply that, since I've got 2 half circles, 2 half circle bases. I'm going to multiply 25 pi over 2 by 2. My 2's cancel. Leaves me with 25 pi units squared. So I'm going to add that with my rectangle area there and my lateral purple area there, and add those up to get 20 plus 35 pi units squared. So there's an example of a kind of a strange figure. Actually, there's a better way to do this problem. As I was doing it, I realized that since it is a C&P flat top, I could have done this quicker and cut this process out. I could have cut this out and used the whole perimeter here times the height to get that lateral area, and then just add on my bases. So anyway, could have improved that solution, but hopefully that's enough for you to make sense of it. As I glance through some of the homework problems, I see another example another homework problem. Again, not assigned, but number 8. 8 has a cone on top of a cylinder. So you would need to be able to solve a problem like this. They gave this height to be 7 meters and this to be 4 meters. This is like maybe a grain bin or something like that. I'm going to find the surface area. Now when you find a surface area of a figure like this, you need to be thinking about what is actual surface. So for example, what I want to find is, I really want to find the surface area of this figure, I want to know the lateral area of the cone. I want to find the lateral area of the cone. That would be all of this. Lateral area of the cone. And I'm going to add that to the lateral area of the cylinder. Let me try spelling that right. So we're going to add that to the lateral surface area of the cylinder. That is this, all the way around. And then we're going to add that to the last part is the area of the base, which looks like this. And notice I would not calculate and add in there the area of this base, because that is inside and it is not a surface. So hopefully that makes sense to you, that I really only need to find, I need to break this problem down into 3 parts. Lateral area of the cone, that's red here. Lateral area of the cylinder, that's orange. Lateral area, area of the base, that's purple. And ignore, do not include the green area, because that base is not a surface. Okay? With this information, the information given, 7 and 4, we're back to basically the first examples that I did. I'm simply finding a cone and a cylinder. You can handle that at this point. But just a little tip on how to view these problems. Okay? So hopefully that helps you navigate some of those problems for tonight. Good night. Have a great weekend.